Recording in progress. So we are starting with exercise 12C, question number 12, sub question 1. I hope you all have the textbook in front of you. Okay, the section of a window consists of a rectangle surmounted by an equilateral triangle. If the perimeter is given to be 16 meters, find the width of the window in order that the maximum light will be entering the window or may be admitted. Okay, so first of all, we'll draw a rough diagram, right? So this is the rectangle, and above it there is a triangle, equilateral triangle. Okay, so now the length is x and the breadth is y. Okay, so naturally the sides of the equilateral triangle will be x. Okay, sides of the equilateral triangle will be x. Now perimeter of this entire window, I remember our discussion last time and I have confirmed it from many books. We have to take the periphery. So this particular side is not allowed. It's not on the periphery. Okay, so the perimeter of this window is 16 meters. So if we start our journey from here, so this plus this plus this plus this plus this back to this particular point is 16. So can someone frame an equation and tell me what is equal to 16?
3x plus 2y.
Correct. So P is equal to 16, perimeter is equal to 16. So 3x plus 2y is equal to 16. So after this, how 3x? This three sides and this two sides. Okay. 3x plus 2y is equal to 16. Right now, after this, you can write x in terms of y or y in terms of x, but then that decision will take later on. I hope everybody has copied this particular slide. Okay. Next one. Now, this is the given condition. If you remember the discussions on maxima, minima, there will be one given condition and there will be something to maximize or minimize. So we have to maximize the amount of light entering this window. So light will enter through the entire window. Light will enter through the entire window. So it will enter through the rectangular part as well as the triangular part. So that's the area, right? So we have to maximize the area. So I'll write down the objective. To maximize area. Now area is equal to area of triangle plus area of rectangle. Area of triangle is root 3 by 4 side square. That's the formula of area of an equilateral triangle. Root 3 by 4 side square. And this is length into breadth. You have the diagram right in front of you. You people are drawing that. Have drawn that. So what is the side? Can someone tell me? Side of the equilateral triangle.
X.
Correct. Side of the equilateral triangle is x. Length into breadth. So x into y. Length into breadth is x into y. So this is area. Now see, we'll replace y from the previous page. We'll replace y from the previous page. So this gives me 2y is equal to 16 minus 3x. So y is equal to 16 minus 3x upon 2. Okay. Y is equal to 16 minus 3x upon 2. So that value I'm going to put on the next page where there is y. You can write along with me, practice along with me. Be focused. X into 16 minus 3x upon 2. Okay. Now we are going to simplify this. See. X into 16 is 16x. X into 3x is 3x square. So I'll just multiply that x with both the terms. Should I go to the next slide? Yes or no?
Yes.
So A is equal to root 3 by 4 x square plus 16x minus 3x square by 2. 16x minus 3x square by 2. Now again I'm going to take LCM. I'll multiply and divide this with 2. So root 3 by 2 x square. So the common denominator will be 4 plus 32x minus 6x square. So 4a, 4 is a constant, just shift it on the right hand side. Even if you don't shift, that's fine. Okay, it's a constant, so we are shifting. So now let this be a1. So we have arrived at function of x. So we have simplified this and we have arrived at function of x. One more thing we can do, we can take x square common. So root 3 minus 6 x square plus 32x. Okay, so we have arrived at a1. A1 is the simplified form of area, and a1 is equal to 4 times a. Okay, so this is a1. Please copy this. Yeah, so a1 dash root 3 minus 6 into 2x. Why 2x? Because the derivative of x square is 2x plus 32 plus 32. Okay, a1 double dash second order derivative root 3 minus 6 into 2, 32 is 0. Okay, so this is equal to twice root 3 minus 6, a1 double dash. Okay, and this is a1 dash. Step 1, a1 dash is equal to 0. A1 dash is equal to 0. So 2x root 3 minus 6 plus 32 is equal to 0. 2x root 3 minus 6 is equal to minus 32. So x is equal to minus 32 upon 2 into root 3 minus 6. I've cross multiplied 2 and root 3 minus 6. So x is equal to minus 16 upon root 3 minus 6. Now x is a side, it cannot be negative. Okay, so x upon 16 upon 6 minus root 3. So this minus sign, the minus sign over here, okay, I'm taking it down in the denominator. So this reverses 16 upon 6 minus root 3. Now if you calculate this, using a calculator, it will be 3.75. X will be 3.75. Okay, or you can keep this as it is, also not a problem. So x is equal to 3.75. You can calculate this over the calculator. Fine. So we got the value of x. Now this x value we are going to put in second order derivative. See, maxima minima problems, you have to prove maxima or minima. Okay, don't just do step 1 and go to the conclusions. There are marks for proving maxima and minima. So step 2, put x is equal to 3.75 in a1 double dash. Now a1 double dash is equal to twice root 3 minus 6. Okay, twice root 3 minus 6. Right? Yeah. Now see, there is no place to substitute the value of x as 3.75. So what can we comment? What is this value? Is this greater than 0 or lesser than 0?
Less than 0.
This is lesser than 0, obviously, because root 3 is 1.732 minus 6, that is negative. Negative into 2 is always negative. Any negative number into 2 is always negative. Okay. No need to calculate also. It's very basic common sense. If you want to calculate, you can certainly calculate, but then not required. Okay. So we got the value of x. We got the uh, function double derivative as lesser than 0. Therefore, a1 has maxima at x is equal to 3.75. Okay. Now they're asking you the width. Okay. Now width is the smaller side of the rectangle. Width is the smaller side of the rectangle. So the smaller side of the rectangle is y. Okay. Y is equal to 16 minus 3x by 2. So y is equal to 16 minus 3x by 2. So we'll find out y. Then we will see which one is the smaller side. So 3 into 3.75 upon 2. Can someone calculate this and tell me what is the answer? 16 minus 3 into 3.75 upon 2.
The 2.3.
So 4.625.
Upon 2. You're not dividing by 2.
2.375.
So, but it's asking for the width, so why do you have to calculate y?
So that's what I said. Key x and y, right? So these are the sides of the length and breadth of the rectangle. So width is the smaller side, right? So that is 2.375. Okay. I think textbook people have given the length, but then we have to find out the breadth, because breadth in this case is the smaller side. So length is equal to 3.75 meters and breadth is the width in this particular problem. That is 2.375 meters. That ends the entire problem. This is the end of the solution. So I'll wait for you. You people have written down the solution. I'm keen on solving the doubts, if any, on this particular problem. If you have doubts, you are supposed to ask. If you are having doubts, you can please ask. Okay. You can refer this recording later also. Yeah, question number 12, sub question 2. I'll be solving right now. Should I? Yes, everyone, please tell me, should I solve question number 12, sub question 2? Yes or no? Just waiting for your feedback. Hello.
Yes.
Okay, great. So 12, sub question 2. A figure consists of a semicircle with a rectangle on its diameter. So 12, sub question 2. We have a semicircle on a rectangle. Fine. So let's first draw this particular rectangle. Okay. We'll draw a semicircle. Okay. Excuse me for my diagram. Okay. Now, this is x and this is y. So technically speaking, what is the radius of the semicircle? Can someone tell me?
X by 2.
This is going to be x by 2. This is going to be x by 2. Fine. Okay. Now the perimeter is k. Something is constant and that constant is the perimeter. Okay. Now perimeter is this particular part. I'll just highlight it and show. This entire part. So x plus 2y plus half of the circumference. Perimeter is x plus 2y plus half of the circumference. Okay, so I'll take you to the next slide if you have copied this. Perimeter is k, perimeter is a constant. So perimeter is equal to x plus 2y plus half of the semicircle, circumference of the circle. P is equal to x plus 2y half of semicircle, circumference of the circle, or 1 second, I'll just write this once again. Half of the circumference. Okay, so k is equal to x plus 2y, circumference is 2 pi r, and r is x upon 2. R is x upon 2. Fine. Okay. So k is equal to, from here and here I'm taking x common, 1 plus pi by 2 plus 2y. Okay. So 2y is equal to k minus x 1 plus pi by 2. Okay. So 2y is equal to k. Let's open the bracket. Okay. So y is equal to k by 2 minus x by 2 minus x pi by 4. K by 2 minus x by 2 minus x pi by 4. Cross multiplying this 2. I'm cross multiplying this 2. Fine. I hope everybody is getting the point. Are you copying, everyone? Yeah. So what we have to maximize? We have to maximize the area. We have to maximize the area and find out the dimensions. So dimension is length, breadth, and radius of the semicircle. Yeah. So in the next page, I'm going to write to maximize the area. Objective. This is going to be a lengthy problem. To maximize area. So area is equal to area of rectangle plus area of semicircle plus area of semicircle. Fine. So area of rectangle is length into breadth. Area of semicircle is half pi r square. Okay. So length is x, breadth is y. Half pi x by 2 the whole square. Half pi x by 2 the whole square. Okay. Now y value we already have calculated. Okay. Y value is k by 2 minus x by 2 minus x pi by 4. K by 2 minus x by 2 minus x pi by 4. Okay. Half pi x square by 4. Fine. Okay. So you have to keep a lot of patience while solving this. So multiply x with all the terms. Area is equal to kx by 2, kx by 2 minus x square by 2 minus x square pi by 4 plus pi x square by 8. pi x square by 8. This part. I'll take LCM. 8. So 4kx minus 4x square minus 2 pi x square plus pi x square. So 8a. 8a is equal to 4kx minus 4x square minus pi x square. Okay. Now let this be a1. Okay. So we got the value of a1. 8 is a constant, so I cross multiplied. Huh? This is not a compulsion, but then I always do this. You people know. Okay. So this is a1. Can someone tell me what? Can someone tell me what is the next step? Anyone?
Derivate
After correct. How many times you have to derive?
twice.
Twice. So a1 dash. A1 dash is equal to 4k minus 8x minus 2 pi x. Okay.
So can you show what you got y as once again?
Yeah, sure. Why is this? K by 2 minus x by 2 minus x pi by 4.
Okay, yes. Thank you, sir.
No problem.
So
Yeah, tell me.
in the previous sum, you had taken x square common. So here also you can do that.
Yes, absolutely. We can take that. We can take x square common, minus x square common. Okay. Chalo, so some people are suggesting to take that common. That is a better idea. A1 is equal to 4kx minus x square pi by 4. Okay. Now we are going to derive this twice. A1 is this. So A1 dash is equal to 4k minus 2x plus pi by 4. Okay. And A1 double dash, I'll just write it over here. A1 double dash, second order derivative. Fine. So second order derivative is equal to minus 2 pi plus 4. This part is 0. Derivative of x is 1. Fine. Okay. So this is the second order derivative. Okay. Step 1. You can solve on your own and tell me what is step 1 answer. The value of x you will get. Step 1. A1 dash is equal to 0. Okay. So 4k minus 2x pi plus 4 is equal to 0. So x is equal to 4k upon 2 pi plus 4, 2k upon pi plus 4. This is x. Step 2. Put x is equal to 4k upon pi plus 4. Sorry, 2k upon 5 plus 4. pi plus 4 in a1 double dash. Now a1 double dash is equal to negative 2 pi plus 4. There is no way we can substitute the value of x in this. But then, can someone tell me this is greater than 0 or less than 0?
Lesser than 0.
This is common sense. All values are positive, lesser than 0. Therefore, maxima. We have proved it is maxima. There is one mark allotted for step 2. You cannot just run away with the value of x. You have to prove maxima and minima. This I am telling again and again. Still I get the same doubts. Okay. Now they're asking you the dimensions. So we got x. X is the length of the rectangle. Okay. So this is the length. Can someone tell me, looking at your notes, what is the radius?
X by 2.
X by 2, no?
The radius of the semicircle is x by 2. So the radius will be k upon pi plus 4. If x is equal to 2k upon pi plus 4, x is equal to 2k upon pi plus 4, x by 2 will be k upon pi plus 4. This is the radius. Okay. And now we are supposed to find out y. Calculation of y will be a task because too many calculations will be there. So I'll take you to y. Okay. Length and radius. I hope you people have understood this. So y is equal to k by 2 minus x by 2 minus x pi by 4. We already know the value of y. You people have copied it. So k by 2 minus half 2k upon pi plus 4 minus 2k upon pi plus 4 pi by 4. Okay. Right. Now this is not very difficult as it seems. The LCM is 4 pi plus 4. LCM of this term, and this term is 4 pi plus 4. Okay. So what will be k multiplied with?
2 into pi plus 4.
Very good. 2 into pi plus 4. As I said, it's not going to be very difficult. Minus 2k will be multiplied with 2 minus 2k pi. So just simplify this and tell me what is the answer of y. Just simplify this and tell me the answer of y. K upon pi plus 4. This is going to be k upon pi plus 4. Now we will be solving question number 19. If any problem is not covered up today, please don't worry. I'll just cover it up later on. Don't worry about that. But then most of the things will get covered up. Don't worry. So I'm just keeping this slide for you, a set of slides of the 12th entire problem, first and second. If you are having any doubt, you may please ask. Each and every problem requires 2 to 3 times practice. So without practice, if you're attempting these problems, you will not get anything out of it. So you have to practice very rigorously. Okay, so if you're not having doubts, I will just erase it and I will take you to question number 19.
So can you go to the previous slides for the second subform?
Yeah. So this is the First slide. I'll go slide wise. Second slide. Third slide.
So can you go to the second slide? So done.
Third slide. See. Fourth slide. Fifth slide. And the sixth. Yeah, I'll be taking you to question number 19 right now. It's not very simple. Just focus on that. Yeah, so let us go to question number 19. Yeah. A wire of length A is cut into two parts, which is bent respectively in the form of a square and a circle. So we have this wire. This is converted into a square and a circle. The side of the square, let it be X. The radius of the circle, let it be R. Okay. So don't you feel the length of the wire is equal to perimeter of the square plus the circumference? The wire is getting converted into the square and the circle. So don't you feel perimeter is equal to circumference plus the perimeter of the square? Yes or no?
So can you repeat?
This wire, it is getting converted into this square and this circle. So maybe in between somewhere I convert this into square. I give it a form of a square. The remaining part I bend it, okay, and it is now a circle. And I join the two endpoints in a curved path such that it is a circle. So don't you feel the length of the wire is equal to perimeter of the square plus circumference of the circle? Yes or no?
Yes, sir.
I hope you can imagine that. Yeah. So I'll just write down length of wire is equal to perimeter of square plus circumference of circle. Okay. Now length of wire is A, perimeter of the square is 4x, circumference of the circle is 2 pi r. So A is equal to 4x plus 2 pi r. Sorry. So A is equal to 4x plus 2 pi r. Okay. Now you can write r in terms of x or x in terms of r. Not a problem. A is a constant. Okay. So 2 pi r is equal to A minus 4x. So r is equal to A minus 4x upon 2 pi. radius in terms of side. Okay. Now what has to be maximized or minimized? Can you tell me? What has to be maximized or minimized?
The sum of the areas.
Correct. Objective to maximize area.
So you have to minimize it.
1 second, let me read. Yeah, sorry. So we have to minimize. We have to minimize. See, least they are saying, na? Least value. So it is minimization. So area of square plus area of circle. Area of square is side square. Area of circle is pi r square. So this is x square plus pi r square. Now r value we have calculated. R is equal to a minus 4x upon 2 pi. A minus 4x upon 2 pi. Okay. I'll show where it is written. See, r is equal to a minus 4x upon 2 pi. I hope everybody is copying quite clearly. Yeah. Then this we are going to simplify. X square plus pi a square minus 8ax plus 16x square upon 4 pi square. So this pi and this pi is gone. This pi and this pi is gone. Now we'll take LCM. We'll multiply 4 pi over here. Take your own time, but then don't copy anything wrong. Okay. And even if we don't take LCM, that's fine. If you want to take, you can take LCM. Otherwise, it's okay. So A is equal to, I'll go ahead with the LCM part. 4 pi x square. 4 pi x square plus a square minus 8ax plus 16x square plus a square minus 8ax plus 16x square upon 4 pi. So 4 pi a is equal to, I'll take x square common over here, 4x square common to be precise. So pi plus 4. So from the first and the last term, I have taken 4x square common. Okay. Plus a square minus 8ax. So now this I will term it as a1. Then a1 dash and a2, a1 double dash. Okay. So 8x pi plus 4 minus 80, that is a1 dash, and a1 double dash, 8 into pi plus 4. So guys, see, don't skip a lot of steps in this, especially during the algebra part. Otherwise, you'll go wrong somewhere. LCM is also occurring quite frequently. Now 4 pi I'm multiplying over here because 4 and pi both are constants. You cannot multiply x terms on the left hand side. So 4 pi a, I'm taking it as a1 for the simplicity of the problem. And that of course is your choice. It's not a compulsion. You can also keep 4 pi on the right hand side and solve. But then I guess this is the better option. Step number 1. a1 dash first order derivative is equal to 0. Okay. So by solving this, can someone tell me what is the value of x? By solving this, can someone tell me what is the value of x? Equate a1 dash to 0.
Pi
I hope
plus 4.
A upon pi plus
everybody is practicing along with me. A upon pi plus 4. A upon pi plus 4. Fine. Step 2. Step 2, you people are solving. Put x is equal to a upon pi plus 4 in a double dash. A1 double dash. Now we really cannot put the value of x. So directly we can comment a1 double dash is, anyone? It is
Greater than 0.
Greater than 0.
greater than 0. And if a1 double dash is greater than 0, hence
Minima.
minima.
A1 has minima.
This steps you have to write. You have to conclude that it has a minima. There are marks for it.
So won't the denominator be 4 pi square?
4 pi square where?
Because the whole of r was squared, right? So 2 pi was in the denominator.
Wait, let me check. So this pi and this pi got cancelled, no?
Oh, okay, okay.
Yeah, no problem. So we got the value of x. X is equal to a upon pi plus 4. Now x is the side of the square. We are interested to calculate all the dimensions. Okay. So we need to find out the value of r. R is equal to, can I go to the next slide? Please tell me. Okay, so r, I'll take you back to r. A minus 4x upon 2 pi. R is equal to a minus 4x upon 2 pi. Okay. So a minus 4x upon 2 pi. X is a upon pi plus 4. So take LCM, a into pi plus 4 minus 4a upon 2 pi plus 4. After you take LCM, this two terms, these two terms will be, the green colored terms will be denominators after taking LCM in the numerator. So R is equal to 4a gone. So what is the value of R? Anyone? What is the value of R?
So I
Yeah,
got
tell
a pi minus 4a plus 8 upon 2 pi square.
I
No
got
idea.
a upon 2 pi plus 4.
Same.
So 4a will be gone. So just open this bracket now. All calculations are there in front of you. A pi plus 4a minus 4a 2 pi plus 4. So 4a is gone. Pi is gone. So R is equal to a upon 2 pi plus 4. Yes. Are you getting the same R? Value of R?
Yes, sir.
So now see, the problem doesn't end over here. We need to prove also that the sum of the areas is a square by 4 pi plus 4. Okay. So first find out area of the square, add it to the area of the circle. The total should be what is asked in the problem. So area of square, 4 into side, 4 into x, and x is a upon pi plus 4. Area of circle, pi r square, r is a upon 2 pi plus 4. A upon 2 pi plus 4 the whole square. So this is going to be a square pi 4 pi plus 4 the whole square. Total area. Area of the square plus area of the circle. Okay, take LCM. So it is going to be 4 pi plus 4 the whole square, right? So this will be a square pi. The first term is going to be 4a into 4 pi plus 4. Please solve this.
So isn't area side square? So why have you done 4 into side?
That's why it's x square, not the area of a square.
Yeah. I'm really sorry. I'm sorry. I took the perimeter. So this is x square. I'm really sorry. So this is x square. Side square. X square. X is a upon pi plus 4 the whole square. A square upon pi plus 4 the whole square. So those changes you have to make it over here. A square upon pi plus 4 the whole square. Take LCM and solve further. So the first term you have to multiply and divide with 4 to get the LCM, and then take a square common. Okay. So a square 4 plus pi upon 4 pi plus 4 the whole square. One term will get cancelled, hence proved. You can take a look at the solution. The question. Towards the end, they are asking the total area is a square by 4 pi plus 4. Okay. Yeah. Let us go to question number 20. Question number 20. Should I? Yes or no?
So can you wait 1 second?
Yeah, sure. Should I? Hello. So I'll start with question number 20 right now. Okay. Given the total surface of a cone. Okay, now that statement is very important. The first statement before the comma. Given the total surface area of a cone. Total surface area. So whenever it is said given, so that means that particular thing is a constant. The same thing, the same logic is applied in so many other problems. If something is said that given it is a given it is a volume, or given it is a total surface area, or given area, so that particular entity becomes a constant. So total surface area of a cone is a constant. Given, again and again I'm re-emphasizing on that statement, given the total surface area of a cone. So total surface area of a cone is a constant, K. Okay. So that the volume has to be maximized and the semi-vertical angle is sine inverse 1/3. Okay. Right? We'll be going very slow, but then you should understand this problem. So I'll draw a cone for you. Fine. This is R, this is L, and this is H. R, L, and H. Okay. Draw a cone. And then R and H. L is the slant height, H is the altitude, the perpendicular height, and R is the base. Now total surface area of a cone is pi r L plus pi r square. You should know this total surface area of the cone, where pi r L is the curved surface area and pi r square is the area of the base, which is a circle. So this is constant. Total surface area is a constant. So pi r L, we are trying to decode some information from here. K minus pi r square. So L is equal to K minus pi r square upon pi r. K minus pi r square upon pi r. Okay. Now, what is the objective of the problem? What is the objective of the problem? You can choose to revert. What is the objective of the problem?
Volume of cone is maximum.
Maximize.
Correct. To maximize the volume of the cone. I hope everybody has copied this. Objective to maximize volume of the cone. So V is equal to 1/3 pi r square h. So 3V by pi, 3 and pi are constants, is equal to r square h. Okay. 3V by pi r square. We'll keep it as it is. Now h. Okay. We'll focus on this h. H we'll find out using Pythagoras theorem. Guys, can someone tell me what is the value of h from Pythagoras theorem over here? R square plus h square is equal to L square. So h square is equal to L square minus R square. So h is equal to root of L square minus R square. Okay. Root of L square minus R square. The problems involving root, I have already given my comment in the previous sessions of Maxima Minima. The problems involving root. So if we don't want to play with this root, what can be done?
Square both sides.
Correct. Square both the sides. So 9v square upon pi square is equal to r raised to 4 L square minus R square. Okay. Right. So let this be V1 R raised to 4 L square minus R square. Now L value we know, we have taken that effort to find out the value of L. K minus pi R square upon pi R. So that value we are going to put it over here in place of L. So please solve along with me. Don't go ahead. Otherwise there will be mistakes. If you're copied till here, please wait. Yeah. So V1 is equal to R raised to 4 L square minus R square. Now L is K minus pi R square by pi R. K minus pi R square by pi R. The square of this. So we have replaced the value of L with K minus pi R square upon pi R. Now this is no rocket science. This is pure algebra. Okay. You have to just simplify. Go on simplifying. Definitely you will get the right answer. So start along with me. R raised to 4 K square plus pi square R raised to 4 minus 2K pi R square upon pi square R square minus R square. So I've taken A minus B the whole square in the numerator, and down it will be pi square R square. Now take LCM over here. V1 is equal to R raised to 4 K square. Write very clearly. If you're writing clearly, things will be quite easy for you. Don't write in the format of rough. Okay. So now guys, this term and this term is getting cancelled.
So it should be minus now.
Yeah, it should be minus. Yes, sorry. Okay. Thank you. And at the same time, R square will be cancelled and this is going to be square over here. Okay. Next step, I'll send this pi square over here to make it more simple. Okay. This slide seems to be very difficult, but then it is not. Keep a very positive approach. Write things very clearly. Okay. And practice each problem of maxima minima 2 to 3 times. Okay. Now I'll multiply pi square on the other side. So pi square V1 pi square V1 equal to, I'll multiply R square with all the terms in the bracket. R square K square or K square R square minus 2K pi R raised to 4 minus 2K pi R raised to 4. Now this I will take it as V2. Now there is no further scope for simplification. So V2 dash will be, K is a constant. So we are derivating with respect to R. 2K square R. The derivative of R square is 2R. Minus the derivative of R raised to 4 is 4R cube. So 4 2s are 8. So this is going to be 8K pi R cube. V2 double dash 2K square. 8 3s are 24. K pi R square. So this is V2 double dash. V2 double dash. Okay. Now step 1. What is step 1, guys? V2 dash is equal to 0. V2 dash is equal to 0. Now what is V2? 2K square R minus 8K pi R cube. 2K square R minus 8K pi R cube equal to 0. So what is the value of R? After solving this, you'll get some value of R. I will also solve. You also keep solving. If you get the answer, tell me. R square is equal to
K by 4 pi.
K by 4 pi. So R will be root K to root pi. This is the value of R. Guys, are you getting the same?
Yes, sir.
Yes, sir.
Now put the value of R in V2 double dash. Put the value of R in V2 double dash. Step number 2. V2 double dash is equal to 2K square minus 24 K pi R square. R square is K upon 4 pi. 4 got cancelled. 6. 2K square minus 6K square. Minus 4K square lesser than 0. See, minus 4 into square. Square is always positive. Square of a non-zero number is always positive. And K is not 0. K has a specific meaning in this problem. K is what? K is the total surface area. It cannot be 0. Okay. So K is positive. It's not even 0. It's not even non-zero as in negative. It is positive. So positive number square is positive. Positive into minus 4 is negative. Negative lesser than 0. Therefore, maxima at R is equal to root k upon 2 root pi. Now we'll find out the value of L. We'll find out the value of L. L is equal to k minus pi r square upon pi r. So r square and r both values we have. R square is k upon 4 pi. And R is this. So pi getting cancelled. So 4k minus k is 3k by 4. Okay. Pi root k by 2 root pi. This is going to be difficult. Okay. So 2 ones are 2, 2s are. Okay. Now what is the value that you're getting? Anyone? We'll do one thing. See, listen. Otherwise, this is going to be complicated. Otherwise, just wait. Okay. So this is 4k minus k, that is 3k upon 4. And this is pi. This 2 also I'll take it within the root. Now this is a very crucial step. Root k upon root 4 pi. 2 within the root. Now these two terms will be together. Now please focus on these steps very clearly. This is the last part of the problem. Okay. So what I did is I took this 2 inside the root. It became 4 pi. Okay. These two terms will be together. So the next step I'm going to write as the next step will be 3 k upon 4 pi. 3 k upon 4 pi upon this entire root k upon root 4 pi. I'll just club the root. So eventually this is going to be 3 root k by 4 pi. K by 4 pi. So if you have not understood this step, I'm ready to explain once again, provided you should ask.
So can you
Again,
explain
I'll
it
solve.
again?
Again, I'll solve because this is the last and the crucial part of the problem. So R square value is k by 4 pi. K by 4 pi. Pi and pi got cancelled. And R value, what is R? R value is this, root k by 2 root pi. Root k by 2 root pi. The numerator is going to be 3k by 4 divided by, now this 2 root pi, I'll write root of 4 pi. I'll take the 2 inside the root. Okay. Now these two terms will be written together. 4 pi. Okay. and this entire thing will be the denominator. So 3k by 4 pi, L is equal to 3k by 4 pi. Practice this thing again and again upon root of k by 4 pi. What I did, I grouped this term and this term. I wrote it as 4 pi, and this root I have combined. So 3 root k by 4 pi. So that is your L. Okay, slant height. Now let's go back to the cone which we have drawn. Let's go back to the cone which we have drawn. This part is called a semi-vertical angle. This was done in AOD as well. Okay. Now which trigonometric function is involved in the solution? Which trigonometric function is involved? Hello. Which trigonometric function is involved?
Sine inverse.
Sine inverse. Okay. So what is sine theta? Opposite upon hypotenuse. Sine theta. So the angle opposite to theta is r upon hypotenuse. So sine theta is equal to r upon L. Now what is r? R is equal to root k by 2 root pi. Root k by 2 root pi. So I'll just write root k by root 4 pi. Okay. I'll just put root to all the terms over there. Upon 3 root k by 4 pi. R and L values I have put. Cancel this. I'll get 1 upon 3. So what will be theta, guys? Theta will be sine inverse 1 upon 3. Hence proved. If I'm not wrong. Okay.